In this section, we're going to be looking at ratios of sides in a right triangle, mainly sine, cosine, and tangent. So when you look at a right triangle, we have many right triangles that are similar to each other. And if we remember back to similar triangles, all similar triangles, the corresponding sides are proportional. So the sides could be different lengths, but they are going to be proportional. And then all of our angles are going to be congruent. They are exactly the same when we have two similar triangles. So when we look at right triangles that have a given measure for any angle other than their 90 degrees, so for example, let's say I have a right triangle here that has an angle of 26 degrees, and I have another one, let's say it's a little bit smaller, that also has another angle, also has an angle of 26 degrees. These two are going to be similar to each other. So the sides are proportional, all of the angles are congruent, just because we know that. So we're going to be looking at these proportional sides in what are called trigonometric ratios. Trigonometric ratios. So a trigonometric ratio is when we look at a ratio of two sides of a right triangle. So they have to be like specific sides that we're looking at. And there are three different ratios that we look at specifically. So sine ratio, well, there's more than this, but these are the three main ones that you will see the most often. So it's called the sine ratio. It's labeled in three letters. All of these have three letters that are condensed to. And the sine ratio is the ratio of the opposite side and the hypotenuse. So when you're looking at a triangle and it says find the sine of angle A, so you have to first identify where angle A is, and so it looks like that's over here. And when you see angle A, we are now going to be looking for the sides, the two sides that are opposite and the side that's the hypotenuse. So when you look at this angle, the opposite side is on the opposite side of the triangle of the angle. So this guy over here is our opposite side. And the hypotenuse is always across from the 90-degree angle, which in this case is right here. So hypotenuse is always going to be our biggest side, biggest length. So it goes there on that triangle, but you have to go based off of the angle that you're given. So if that's the case, then I can say that sine of angle A equals the opposite over the hypotenuse. So my opposite side, I'll write this first so we know what we're filling in. So it's opposite over hypotenuse. My opposite side is BC, and my hypotenuse is AB. So that would be the ratio of the sine of that angle. The next one that we would look at is cosine, which is condensed to COS. So the ratio of the length of, this time the cosine, is the adjacent side. Adjacent means next to, and the hypotenuse. We only have three different sides that we can use, so we've talked about all of them so far. Okay, so find the cosine of theta. When you're looking at angles, this is a Greek letter that you will see very often that represents angles, and it's called theta. So to find the cosine of theta, which is marked here over here in angle A, or angle C, sorry. When we find the cosine of theta, we are looking for the adjacent side over the hypotenuse. So we need to label which ones are those. So if this is my angle, I usually identify actually the hypotenuse first so I don't get that confused with anything else. So that's across from my right angle, which is right here. And then the adjacent side is, remember, this is my focus angle over here. The adjacent side is the side that's next to my focus angle. So in that case, that's going to be this one, because the other available side is not anywhere close to that side. So when I fill out the cosine of theta, my adjacent side is CT, and the hypotenuse is CA. So you're just making a fraction out of it. That's all we're doing so far, is we're setting up this ratio. So our third one is tangent, and it's notated as TAN, tangent. So this is the ratio of the length of the opposite side to the adjacent. I'm spelling this wrong. Adjacent, there we go. Okay, so this one says find tangent of B. Remember, we have to look here first to figure out which angle our focus angle is. So angle B is up here, my 90 degrees is here. I need, looking at angle B, I need the opposite, which is on the opposite side of the triangle from it, from the angle. So that goes here. And the adjacent side. Now, both of these sides are next to my angle. However, remember, this is always going to be labeled as the hypotenuse because it's across the triangle from the 90-degree angle. So that means this, one of the legs, has to be the adjacent side. So when I'm setting up tangent of B, I need the opposite over the adjacent. The opposite side is AC, and the adjacent side is BC. So that is my fraction. Those are my ratios for my different legs or lengths of a triangle. So let's look at an example now that has some numbers. So this one says find the sine, cosine, and tangent of angle B. So it looks like we have one focus angle here, which is going to be right here. So I'm going to mark that just so I know where I'm looking. So looking at angle B, it looks like I have the side across from it, which is going to be my opposite side. And I have the hypotenuse over here. Let's label that, which I don't actually have the number for, but we can find that if we need it. And then we have, last but not least, the adjacent side, because the adjacent side is right next to our angle right there, why it's called adjacent. So we need to be able to find all of these things. So sine, again, is opposite over hypotenuse. And it looks like I have the opposite, but I don't have a number here for the hypotenuse, so we'll have to find that. The cosine is adjacent over hypotenuse. Again, I don't have the hypotenuse yet, so we can't do that one. And then tangent is opposite over adjacent. Okay, and it looks like I actually do have both of those. So it says to find the fraction and then round your answer to the nearest 2 decimals. So we'll work on finding the fractions first. So for tangent, I have opposite, which is 5 centimeters, over the adjacent, which is 8 centimeters. And then I plug that into my calculator. And if I round to the nearest 2 decimal places, I get 0.63. So that is approximately equal, since I had to round, 0.63. Okay, so now in order to find the sine and cosine, I need to find the hypotenuse. So I don't have that yet, but it is a right triangle. So I can use a squared plus b squared equals c squared, because I know 2 of the sides already. I actually know the 2 legs. So I can fill in 8 squared and 5 squared, and that will give me c squared. And so I can just square those and add them together, and I end up getting 89 on this side equals c squared. Then you square root both sides. So c equals the square root of 89. And I'm not going to change it to a decimal and round it, because that's not going to be my final answer. I do not want to round my answer until I get to the very end. So I'm just going to use the square root of 89 as my hypotenuse. So now I can go ahead and fill these in. Opposite. My opposite side is 5. My hypotenuse is the square root of 89. Type that in my calculator. 5 divided by the square root of 89. And I get, rounding to the nearest 2 decimal places, is approximately 0.53. All right, adjacent over hypotenuse for my cosine. The adjacent is 8. My hypotenuse is the square root of 89. So again, type that in my calculator, rounding to the nearest, I always forget this, round to the nearest 2 decimal places gives me 0.85. So there we go. My focus angle was B every time. So that helped me identify adjacent, opposite, hypotenuse, so I could find my fractions and go from there. In example 2, we're going to be doing the same thing. However, they're going to change. This is all about angle A, and then this over here is all going to be about angle B. So we're going to change our focus angle. So let's start with angle A. And we don't have any numbers this time. We just have letters. So sine of angle A. And the more you do this, we need to make sure we remember like how to find sine, cosine, and tangent. And very frequently, and you probably heard of this already, we use this spelling, Sohcahtoa. And that's how I spell it. So sine, all of these letters stand for something. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that is what Sohcahtoa stands for. So sine is opposite over hypotenuse. So if I look at angle A, the opposite side is A, because that's on the opposite side. So that's going to be my numerator, and then my hypotenuse, again, always across from the 90 degrees. So that's going to be my C. And there we go. There is my fraction for the trig ratio. Go ahead and pause the video at any time and see if you can fill this out first, and then check your answers afterwards. So cosine of A is going to be adjacent, so the one that's adjacent or next to our angle is going to be B over hypotenuse, which again is C. And then we have the tangent of A, which is opposite over adjacent. So my opposite side again is A, little a, and my adjacent side is little b. So there's that. All right, now we're going to use the same triangle. However, our focus angle this time is B. So now we're looking at the same triangle, but this time I want the sine of B, the cosine of B, the tangent of B. So now looking here, I have my opposite side over here. This is opposite. This guy is adjacent, and C is still going to be our hypotenuse. Our hypotenuse doesn't change because our 90-degree angle doesn't change. So sine of B is opposite over hypotenuse, so that is going to be lowercase b over hypotenuse, which is C. And cosine, if you notice, the cosine of A and the sine of B end up being exactly the same fraction because the opposite and adjacent sides switch depending on what angle you're looking at. So cosine of B is adjacent over hypotenuse. So this time my adjacent side is little a and my hypotenuse is little c. Tangent of B is opposite over adjacent. So opposite side is B. Adjacent side is little a. And make sure you keep your uppercase and lowercase letters exactly how they're supposed to be, because if you change the uppercase and lowercase, it means something different. So keep those how they are. All right, example 3, this would be a good one to pause the video and try it out first, and then check your answers. So we're going to start with angle A over here. And again, sine. Let me write my letters up here for Sohcahtoa. Sohcahtoa. Okay, sine is opposite over hypotenuse. If I'm looking at angle A, the opposite side is 6. The hypotenuse is across from the 90 degrees, which is 10. And we can simplify this. You can change it to a decimal if you want, or you can reduce the fraction to 3/5. All right, cosine of A is adjacent over hypotenuse. So this time my adjacent side, the one that's next to my angle, is 8. My hypotenuse is 10, so I can reduce that to 4/5. Tangent is opposite over adjacent. So still looking at angle A, my opposite side is 6. My adjacent side is 8. I can reduce that to 3/4. Okay, now we switch our focus to angle B. So now looking over here, angle B is the focus. So now opposite side this time is 8. The adjacent side is 6. Hypotenuse is still 10. So sine again is opposite over hypotenuse. So opposite side is 8. Hypotenuse is 10. Can reduce that to 4/5. And again, notice the sine and cosine of angle A and B are flip-flopped of each other. So cosine of B is going to be adjacent over hypotenuse. Tangent of B is opposite over adjacent. So opposite of B is 8. Adjacent is 6. So we get 4/3 for that one. Okay, and you might have noticed this before, but you have all 3 of these trig ratios on your graphing calculator or even on your scientific calculator. They, if you go ahead and look at it, you'll have buttons. You'll see they have sine, cosine, and tangent, and they will all be right next to each other. So since these ratios, these trigonometric ratios, are all the same no matter the size of your triangle, All similar triangles have the same sine, cosine, and tangent since it's a ratio of the two sides. They will all be the same, so it's just a saved, like, standard number every time, no matter how big your triangle is. So if you practice this, you just have to make sure your calculator is in the right mode. So if you will find the mode button on the graphing calculators, it's up by the blue button. It's up by the second button. So if you click on mode, there will be an option between radian and degree, and you just have to make sure that degree is highlighted. So once that's highlighted, you can go back to your main screen. And if it's in degree mode, you just go ahead and type in sine of 30 and try this out. Make sure you're getting the same decimals I am getting, and we are going to be rounding to to 4 decimal places. So 0.5 just turns out to be 0.5. So let's try cosine of 18. Go ahead and type that in, round to the nearest 4 decimal places. So 951, and then that will round up to a 1. Next, tangent of 72, just type it in, and we should all, if we're in the right mode, we should be getting the same numbers. 3.0777, that rounds up to 7 at the end. And sine of 83.9925. Go ahead and practice that in your calculator. If you're not getting the right numbers and you're not sure why, make sure you ask your teacher about it so they can help you out.